Okay, lesson 9 of chapter 1, estimating square and cube roots. So we've talked about squares and cubes in a previous lesson, and we specifically talked about perfect squares and even perfect cubes. So let's review that just really quickly. So a perfect square is any number that has a square root that comes out even. So the square root of 4 is 2. That means 4 is a perfect square. 1 is a perfect square because the square root of 1, 1. So we had 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and we'll stop right here with 169. Now, those are perfect squares because they have a square root that comes out even. So, not all square roots come out even, such as the square root of 8. Square root of 8, if you look, falls right here, right in the middle of, well, not quite in the middle, but let's say between 4 and 9. So that way you know that the square root of 8 should be bigger than 2, but the square root of 9 is 3, so it should be less than 3. That square root of 8 should pop up right in here. So it's in between 2 and 3, but it's going to be closer to one of them. 8 is a lot closer to 9 than it is 4, so the square root of 8 is going to be closest to 3. All right, so we're estimating. We don't want an exact value. We just estimate to the nearest integer. So if you look right here, estimate the square root of 83 to the nearest integer. So the square root of 83, really close to ones that we know, would be 81. The square root of 81 is 9. That would be on the small side since this is less than 83. So we need one on the other side. So that would be 100. Square root of 100 is 10. So we know that the square root of 83 will fall in between 9 and 10. Now, your job, is it closer to 81 or closer to 100? Well, 83 is obviously closer to 81 than 100. It's going to be right in here somewhere. So you know estimating it is closer to 9 than 10. All right, let's go down here and try a few. This time it wants, and it went a little too far. This time it wants a cubed root. So the cubed root of 320. Cubed root of 320. So again, let's talk about some perfect cubes. So perfect cubes would be 1 times 1 times 1, 2 times 2 times 2. That's an 8. 3 times 3 times 3. 4 times 4 times 4. 5 times 5 times 5. 6 times 6 times 6. 7 times 7 times 7. Let's see if that will get us where we need to go. So those are perfect cubes. So if I want to know the cubed root of 320, cubed root of 320 is going to fall in between these two right here. So this cubed root of 216 was 6. Cubed root of 343 was 7, because 6 times 6 times 6, 3 times, will give you 216. So the cubed root of that is 6. So if I want to know the cubed root of 320, even though it doesn't come out even, we know it's going to be in between 6 and 7. So we can't say in between 6 and 7. We need to pick the one that's closest. So 320 is closer to 343 than 216. So the best evaluation we can do for that, the best estimation, would be that the cubed root would be 7. Okay, let's try some more. I want you to pause it for a minute, and I want you to try A, B, C. Really? Well, you know, it is Friday the 13th. I'm recording this video, so it has a mind of its own. Now, let's pretend that that never happened. Get out my Men in Black zapper, zap your memory, and we'll go back to this. A, B, C, and D. Oh yeah, E and F. Try all 6 of those, please. All right, So whenever you're back and we've done these, so the square root of 35 falls in between the square root of 25 and the square root of 36. Obviously closer to this perfect square, the square root of 36 is 6. B, square root of 170. Well, we know that 10 squared is 100. 11 squared, 121. 12 squared, 144. And 13 squared, 169. And 14 squared, I actually don't know off the top of my head. I know, I'm letting you down, right? I'm so giving way to that mathematical mysterious magic that you thought I had. 5, 0, 4, 1, 196. Yeah, I knew that all the time. I was just testing you. 196. So we've got one now on both sides of this. So we've got 170 would fall right in here. Obviously closer to 169 than 196. So that means this was 10, this was 11, this was 12, this was 13. So my answer to be 13. C, 44.8. Does not matter that it's a decimal. Same kind of thing's still going to happen. So I know right around there I would have the 36 is a perfect square, and one bigger than that would be 49. So I've got 36 and 49. If it's somehow closer to the middle, it may be helpful for you to subtract, maybe 44.8 minus 36 and 49 minus 44.8, just to see which one's closer. You're going to come out that this one's closer. Now, this is not the answer. It wants the square root of that, so we're going to estimate this as the square root is 7. The cubed root of 62. Cubed root of 62. You know, it might help you to have a chart. Hopefully you wrote that one down at the beginning where I talked about perfect squares. And perfect cubes. So, perfect squares, if you want to go ahead and list them out. 1, 4, 9, 16. Come on, honey. 16. 25, 36, 49, 49. What comes after that? 64. And 8 times 8 is 64. 9 times 9 is 81. 100. You may want to go a little farther. 11 times 11 is 121. And we've got 144, 169. We just found out that that was 196. 14 times 14, 196. And 15 times 15 is 225. So if you want to go ahead and write all those out. So those are perfect squares. Perfect cubes, might be helpful to have a list of those as well. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. Obviously, whenever you're cubing something, you get higher really quick in your values. So 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6. 216. 7 times 7 times 7, 343. That's at least a list for you to get started, and then we can go from there. So the cubed root of 62. So if we're talking about cubed roots, go down our chart right here. 62 falls in between here. So it's going to be in between 3 and 4. This is my third cube. This is my fourth one. It's going to be between 3 and 4. 62 is so much closer to 64. So the answer to that is 4. Cubed root of 25. Cubed root of 25 going to fall right in here between 8 and 27. So cubed root of 25 closer to 27, which means that this is closer to 3. Cubed root of 129.6. 129.6 would fall in here. So that is in between 5 and 6. 129 is a heck of a lot closer to 125 than 216. So the cubed root of this estimation would be 5. Okay, so I highly recommend keeping this perfect square chart. Highly recommend keeping this perfect cube chart. Now, this only went to 7, so you might want to extend it, and you have calculators, so that would not be an issue at all. All right, let's move on. So I believe we're going to skip this next example here, unless anyone wants to talk about truncating decimals, which I highly doubt. Some of you may not even be able to pronounce that. I had to practice. All right, let's look at the guided practice. So estimate to the nearest integer. I want you to pause and try 1, 2, 3, 4, 5, and 6. All right, back with me. Let's talk about some answers. Number 1, closest to 5. 2, closest to 12. 3, closest to 6. 4, closest to 4. 5, closest to 6. And 7 is 5. Now again, we've talked about this all lesson, throughout the lesson, but I want to just emphasize just a minute. We are talking about estimating. So we're not going to have an exact answer. This is our best educated guess. And it says to the nearest integer. So remember, integers are the numbers you see on the number line. Could be positive, could be negative. But when you talk about square roots, they're always positive anyway. So we are talking basically like to the nearest whole number, if you want to think about it like that. So it's the best educated guess. Doesn't mean you can guess any number and it be right. But you should use your chart of perfect squares and perfect cubes. And this lesson should be easy and simple. So have any questions? Let me know tomorrow. Good luck.